data science that I have finished in 2015 from the University of Hardik in England. And my dissertation title was Investigative Study of the Social Media and Development of the Private and Secure Social Web in 2015. My research area of specializations are artificial intelligence, cybersecurity, machine learning, big data, IoT, and social media. In my research portfolio, I have published three books, one book chapter, and more than 50 publications in the journals and proceedings of international and national conferences. Kyla, could you please check whether my voice is appropriate or not?
Yeah, I think it sounds okay.
Okay, perfect. Yeah, so this is what about the outlines of the today's boot camp. In this today's we are going to do dividing a session in two different activities. The one is one information that we are going to learn, that what is AI, what is data science, what is machine learning, and all those things. And we will talk about the data science and machine learning libraries and examples with the libraries. And the second part will be hands-on activities. So I'm gonna show some hands-on exercise that you can do by using open source tool of the Google, and you can do some analytics and some mathematical experiments and little fun. So I'm gonna show you that demonstration today, and in tomorrow all participants are required to do like hands-on activity by themselves. And you might be familiar with the agenda that I have sent, that we are announcing first, second, third winners tomorrow, those who will perform extraordinary in the hands-on activities of this data science boot camps that we will be doing by tomorrow. So let's start with definitions and some primary understandings and overview of the data science. So first of all, before we gonna talk about artificial intelligence and data science and everything, let me mention that first of all, what is a natural intelligence? Okay, so like you are a high school students and you will be going to the universities very soon. So you will learn about STEM activities and STEM fields and everything. So right now, like data science, cybersecurity, and AI, and also cyber physical system, edge computing. So these are the current cutting edge of the technologies that whole world is working on. Not only academicians and researchers, but industries and also developers, those who are building useful tools in the market. But first of all, like what is a natural intelligence? So the natural intelligence means if we are responding to the situation with flexibility, that is one of the characteristics of the natural intelligence. So let's say, for example, somebody comes to me and offering an ice cream. Okay, if I'm in a good mood, I would happily take the ice cream and eat the ice cream. But let's say if I'm not in a good mood, then what happens? I may not accept and I may not feel happy. So I do have a flexibility. Okay, it is not hard coded that I would be behaving this way. My behavior will be flexible based on the situation, moods, and everything. The second is make sense of ambiguous or erroneous messages. So let's say, for example, if there is some messages are passing or communication is going on, however, it is using the normal text, but if there is some ambiguous or erroneous is there, which is not according to the text, but makes sense as per the understanding of the human beings and experience. So that is a part of the natural intelligence. Another is the assign relative importance to the elements of the situation. For example, let's say if something happens, you can relate that what is how it is important and what are the elements associated with it. But if it is if it is not natural intelligence, then you cannot get through with the relative importance and the elements of the situation. Another thing is find similarities, even though there is a situation is different. So have you heard about? I mean, you might have experience about like two different pictures. So you have given picture one and you have given a picture two. And what you need to do, like you need to find the difference between those two pictures, although they both of them look same. That can be done by the natural intelligence only. Okay. Then nowadays artificial intelligence is doing so many good things, but like we are talking about the natural intelligence here, draws distinctions between situations through there may be many similarities between them. So like the thing is, these are the characteristics of the natural intelligence, and you can see the natural intelligence is available highly in the human being and at certain level to the animals and other lives available on the earth. Now, what is artificial intelligence? So artificial intelligence, actually, there are so many. If you search in a Google and if you do Wikipedia, you will be seeing like there are so many definitions. I can tell you like there are more than 100 definitions of the artificial intelligence. But the thing is that when I have started studying about the AI in 2006, no, 2007-8 time frame. At that time, AI was just a theory. There were no any concrete intelligent software available. People were talking about knowledge-based system, database system, expert system, and genetic algorithm and neural network and all those. I mean, if you are reading about data science, you might have heard these terminologies. But actual AI, which is happening right now, which is a deep learning and all, it was not there at that time. And that time I have studied a book, and that book is Artificial Intelligence, written by Ellen Rich with McGraw-Hill Publications. And in 1986, they have published about AI, and that was just theoretical concept. So as per their concept, what is artificial intelligence over here? So you can say like artificial intelligence, this is the best definition that I like and I can deliberate for sure, but there are like 100 of definitions available. So AI is the study of how to make a computer do things at which at moment people are better. So this is the general universal definition you can say about the AI. So whatever normal people can do better way, all those things can be done by machine that calls artificial intelligence or done by the computer. That is also called the artificial intelligence. So here you can see like, it's a study of like how we can make computers so robust, so intelligent that people, whatever they are doing, the same kind of things computer can do. Okay, nowadays if you are seeing the application, you can see the smart drone, you can see the smart web, you can see the smart car, you can see like autonomous car. Okay, so what are, all are these applications? These all are the applications of the artificial intelligence. You see like Uber is investing $1 billion just to do the research on autonomous car. Same as Google has also launched his their autonomous car. You just need to go and sit into the car, and you just need to tell them like, I just want to go to this location, and car drives by itself and get you that to the destination. So these are all the applications of the AI. There are also many applications of the AI that we are going to discuss here, but these are like happening state of art technologies in the market. So that is what the artificial intelligence. Then you might have like questions like, we are learning data science here, then where the artificial intelligence comes in the picture. So let me tell you that AI is a superset, that is the main, and artificial intelligence is the division of the AI. So whatever we are, sorry, data science is the one of the division subset of the AI. So whenever you heard the terminologies like data science, data analytics, machine learning, deep learning, natural language processing, and all these things and all these algorithms and applications are the part of the artificial intelligence. Okay, so let's see like what are the constitutions of our AI. So here you can see there are six different constituents of the AI. These are not like hard six components, but these are like if you are talking about the intelligence in the machine and computer, these are the minimum requirement you can say. So you would be saying like human thought process. So like whatever human can thoughts, machine can also thoughts. So that process is one of the component of the AI where people are better. So as we have seen in the definition that whatever people are doing better way, that should be done by the machine or the computer. Another is the characteristics we associated with intelligence, then knowledge using the symbols, non-algorithmic. This is most important. Like non-algorithmic means what? If there is algorithm and whatever we have designed in the algorithm, you will be expecting outcome according to the design of the algorithm. For example, I mean, it is not the algorithm, but let's say mathematics. Okay, if you do 1 plus 1, it will be 2. But let's say if you do 1 plus 1, then that becomes 4 or 5 or 10. Is it possible? Of course not. The reason that this is not the normal behavior of the mathematics. The same way that non-algorithmic behavior is in what, like you cannot define, as you have seen in the first slide of the natural intelligence, that the behavior is a flexible. It's not the programmed. Okay. So what is the difference between program and non-programmed behavior? The programmed behavior is the behavior that will behave in a certain way. So let's say, for example, you might have some friends, and you talk to them in a certain way about certain things. Their behavior will be like this. So that is what? That is not algorithmic behavior, but that is what if that kind of behavior is all the time in the history, then yeah, it becomes algorithmic behavior. But let's say the intensity of the behavior is you know poor, good, best, excellent, like you categorize the intensity of the behavior, then it is also not algorithmic. In addition to that, let's say for example, if we are talking about AI, then how we can say that is a AI. So AI is nothing like, it's not like miracle, or it's not like magic, but it is the process that is learning from the data. Okay, and learning from the pattern. So let's say, for example, if you are saying that, if you talk to your friend in a certain way, he or she will behave this way. So that is not the algorithm that you are talking about. It is based on your past experience you are talking about. And that is, we call like pattern learning. So that is what like non-algorithmic, that is what known as a pattern learning. Another thing is like, knowledge using the symbols. Okay, so let's say whatever knowledge you can get through the using the symbols as a human being, that also AI can do. So it is not depends on the text, it is not depends on the other graphics and all, but it learns from the symbols as well. Okay, and other characteristics that also we have discussed. Now, another definition that we are talking about here, like AI and natural AI and all those things. So what are the AI solutions we are talking about here? So as I mentioned that in 1986 they started talking about AI. People started talking about AI, and they talk about like machine intelligence, intelligence system. There were not machine learning and data science concept. There were only like database and all those things. But yeah, people, they were talking about like intelligence system. Now, if they are talking about the intelligent system, so they have also mentioned about the nature of the AI solutions. So let's say they have they were not knowing about like what kind of AI solutions they will be getting, but they were open for AI solutions, but they also define the timeline of the acceptable solutions and the non-acceptable solutions. So consider the situation of the acceptable solution in the acceptable time and the extreme solution, either the best or worst that takes infinite time, that is the extreme solution. So let's say if you have started, developing some system, and that system will take, let's say, 50 years, then that would be like, extreme solution, or you can say like maybe best solution because you need that much time to develop, and that would be the tremendous, useful solution systems or something, or it would be the worst solution because like once you have a system ready with the development, maybe there is no one who can use that system. So that is the reason, like there are two types of AI solutions. We will discuss about it in the applications for sure. And this is little interesting that you can see, that is AI test, that is known as a testing intelligence and Turing test. What does it mean over here? AI test and Turing test. This is more interesting, and this is also like kind of accepted test at the time of like 1986 and 1997. And that was also like we were discussing in 2007 2008, because there were not real intelligence system, there were all knowledge based system. We will also discuss about like what is knowledge based system, what is intelligence system, and all those things. But let's say what is the testing intelligence. So let's say if I'm giving you this phone, okay, I'm just giving you this phone and would tell you like, okay, whether this phone is intelligent or not, just test it for me. So how you can test? What are the parameters for the testing? So that all thoughts came together, and they have defined that this is called as a Turing test, and the system that we are claiming as an intelligent system can pass through this test, that is called the AI test successful. Okay, so this is what we call the Turing test. Now here is the thing that just a second. Yeah, here is the thing that testing intelligence. So testing intelligence means what? That let's say there is a secretary who is sitting in one room, and there is a boss who is sitting in another room. So consider the situation that you are the boss and you are sitting in one room, and your secretary is sitting in another room. You are asking something to the secretary, but instead of your secretary, maybe the computer is replying. And computer is replying, you cannot say that whether it is a computer replied by itself or the secretary replied, then you can say the Turing test is a successful. So that is known as the Turing test, in which at moment the person who is sitting in the one room and communicating with the person sitting in another room, when this person is communicating with this person, but instead of this person, the computer is replying and talking to this person, and this person cannot figure it out whether the reply he is getting is from secretary or from the computer. That means the testing intelligence is a successful. But if this person can easily recognize that, okay, this is not his secretary is replying, then there is a Turing test fails. So this is known as the testing intelligence over here. And this is most acceptable, in the time of like 19s and 2000. This was the only testing methodology that was accepted for the intelligence system. But nowadays, like there are so many testing methodologies, but this is what the general testing methodology over here. Okay, so can you find any test to check the given system is intelligent or not. So these are like, conceptually from conceptual form of the test that use it in a different situation, whether it is accepting, not accepting, and so what are the things over here? So here is the thing, like, react differently. So let's say, for example, you are asking the question to your secretary that what is the phone number of person XYZ. And then what happened that, it is replying something weird that what do you need? Why do you need it? So generally the secretary, she cannot ask to boss that why he needs the contact number of the XYZ. So that means like, there is some different behavior or reaction that is coming out. And that keep you thinking like, oh, whether it is a human or whether it is somebody else. Okay. Another thing is like, makes and understands of the joke. So let's say if somebody is passing the joke, then human being can easily recognize but that it is a joke. It is not the actual talk or it is not the serious talk. Just like your Siri. Okay, if you are using the Apple iPhone, then you are talking to your Siri a lot, then you can realize like, Siri is enough intelligent that if you are, doing some funny jokes with Siri, she also responding you in that way. So that what's like, make understanding of the joke. Solves your problem. Definitely intelligent system, they may or they may not solve your problem. So let's say, for example, if I ask you that what is a addition of like 3 plus 30 plus 50 plus 500 plus 7,000, and if you can answer me within let's say 2 seconds, that means you are not the human being, because human being cannot answer of five different digits, which are like big digit, and their addition and mathematical calculations within 1 or 2 seconds. That is not possible for the human being, normal human being for sure. So if that can be done, that means you can doubt like, oh, this is not the human being, this is the system. Okay, in that case also, Turing test is a fail. However, it is smart and intelligent system. Then the walks, perceives, test, smells, feels like a human. Okay, nowadays, like, people are building a system, and I can also give you the name of the system that can smell. I mean, you just get that like, rose flower to that system, and that system can get that smell and can tell you that this is the rose. So that kind of sensors and smart sensors are available in the market nowadays. So that is what like, I mean, whether based on the walk, it can, differentiate whether it is a kid, whether it is a child, or whether it is the normal human being. They can also identify the health condition based on the walk. So nowadays, like, there is such kind of research is already done in the healthcare system that if, you know, they caption the motion of your walking style, they can tell you whether you are healthy or you are not healthy. Okay, so that kind of smart systems are, common nowadays. And if it talks like human, so that is also like translate, summarize, and learn. So like whatever, they, by using the system, they can translate like Google Translate. And nowadays, like Google Translate is using the semantic web concept. So let's say, for example, you ask something in one language, it translates into the another language, and then also take your feedback and input. That way, Google is taking all the participants who are using Google Translate, and it is asking for their feedback. And then what happens that Google is learning. Google Translator is learning from it. I was reading one article and I was talking to one of the software engineers working at Google, and they said like, there is a TensorFlow. You guys might have heard about the word TensorFlow. So like, you can search it TensorFlow. So TensorFlow is the framework of the Google. And what this framework does, this framework is getting smarter and smarter based on the data available on your email, on your Google search, on your Google, meetings, and also any of the product that you are using from the Google, including Google Maps as well. Yeah. And the best thing is, like, Google is getting more and more smart just because of more and more people they are using who are using that products. So that, like, summarize and translate, that is one characteristic, and learning is also another characteristic. So these are the, like, AI tests that we are talking about. Applications. I mean, I have mentioned about like a lot of applications. Let's say, for example, smart healthcare systems, you know, autonomous car. We also talk about, like, computer vision system that, you use your phone, and based on your face categories, they, unlock your phone. That is just an algorithm. Let's say, for example, computer vision algorithm. But let's say, for example, there is somebody in the social media or some news channel, or let's say some media, they post your photo and picture, then you get automatic notification that somebody has posted something by using your picture. So how this system works? So these all systems are using, data science and machine learning algorithms and AI applications. So nowadays, there are so many AI applications. But let's say, for example, if I ask you whether this system, okay, I'm giving you the system, and if I ask you whether this system is intelligent system or not, how can you differentiate? I mean, how can you give your judgment? How can you give your thoughts, like, whether it is intelligent or not? So in 1991, Rich and Knight, the same book, classified and described the different areas that AI techniques have been applied as follows. These are the areas. The one is a mundane task. The another is an expert task. And the third is a formal task. So if your system can perform any of these tasks that is listed here, then you can say, oh, it is the intelligent system, or it is the AI system, or it is the smart system. Nowadays, like, instead of AI, we are using the word like smart system. So what does it mean by smart? It does, normal things and betterment for the human being, so that makes human life better. So what is mundane task over here? That's a perception, vision, and speech. So whatever we are seeing, based on whatever we are seeing, we can talk and we can speak. So that what we can do. So that is the perceptions we can put about. That is a mundane task. The same if intelligence system can do. The system can do. That is the intelligence system. Another is a natural language understanding, generation and translation and processing. So natural language processing means what? Like, whatever the natural language we are talking, and computer can understand, and whatever computer is talking that we can understand, that becomes the natural language processing. Let's say, for example, I'm talking in one language, let's say in English, but computer, it doesn't understand English because it understands only binary language, that is a 0 and 1. But we prepare a system that is an interface system which allows us to communicate with the machine. So let's say if you are talking to the robot and robot is responding you, how robot is understanding your language? It is using natural language processing. Okay, let's forget about the robot. You are using Siri in your phone. So let's say you are asking Siri that, Siri, please call to my mom. How Siri understand? I mean, Siri is not the person. It's a system, it's a machine. So machine only understands 0 and 1, binary language. But there is one interface. So here is the human being, and here is a Siri, and there is the one interface which is converting the normal natural language into the computer understanding language and computer language to the normal natural language conversion, that is known as a natural language processing. Another thing is the common sense reasoning. So let's say, for example, there is a something which is a part of the common sense. Okay, so what are the examples we can give? So I mean, if there is a, like, relationship identification. Okay, so let's say, for example, a woman, she is having two children. Okay, the one is a boy, another is a girl. So what is the relationship between this boy and this girl? Obviously, they are brother and sister. So this is the common sense and reasoning. So if that kind of reasoning, there is no connection. Let's say, for example, there is no connection for, let's say, give the example. Let's say there is a has a connection with B and B has a connection with C. Okay, but if you ask, let's say, if there is a connection between A and C, what would be the answer? If you are a computer, you are not smart enough, then you would say, no, there is no connection between A and C. But if you are, smart, intelligent, or let's say if you understand the dependencies and these things, common sense reasoning, if you understand, then you can say like, oh, if there is a has a connection with a B, and B is connecting with C, so A implies B, B implies C, so there is a transitive dependency between A and C. Okay, it's automatically happens. Okay, so how, I mean, how this system can learn this transitivity? This can learn by using this common sense reasoning. Another thing is a robot control. Okay, so robot control is like, there is a huge field, there is a big field in the market that you can see as a part of the robotic control. So let's say, for example, robot's arm control. So let's say in particular situation, robot needs to put his, I mean, put up his arm, put down his arm, and you need to control this joint by using what kind of controlling system. So that whole like part of the mundane task. Another is the expert task. So expert task is like, most interesting things that you can say, that the task that only expert can do. For example, engineering task, medical diagnosis, financial analysis, scientific analysis. So let's say, for example, you have a headache. Okay, you have like a headache, or let's say you are feeling not well. You can predict there is some health related issues, but you cannot diagnose you cannot medical diagnosis until and unless you are the expert of the field. Okay, so let's say you need to go to the doctor and you need to go to the medical expert to diagnose of your symptoms, body symptoms. Okay, I mean, you cannot, say like, oh, this would be the things. I mean, you can predict, and your prediction might be, right, like 99%, but until and unless there is no, medical expert gives their advice, you cannot say like, oh yeah, this is what the things that is happening to me. Financial analysis, accounting, engineering tasks, like, building a machinery, controlling the machinery, programming, algorithms, manufacturing, okay, fault finding. Okay, so these are the tasks of the expert task that requires expertise, not only expertise, but knowledge, expertise, and experience in the field. And that's known as the expert task. But the same kind of expertise, if you transfer to the human being, then definitely I mean, sorry, not human being, computer system, then definitely your life will be easy. Why we need the expert task, and why company needs the expert task nowadays? So let's say company, they hire the employees. This is frequently happens to the IT industry. Let's say they hire employees and they train them, and they just go to the another company for better salary and all those things. So whatever the expertise that they built, that just gone away. So their investment, is like, kind of waste for them. So what they can do, like they can build the system that whatever expertise they are giving to the human being, that same kind of expertise and knowledge can be stored in the computer system. So let's say next time the another human being who is the fresher coming to the field and coming to the industry, that expert system or that knowledge based system can be used by that new freshers to learn everything very quick, and it can get into the work very fast. So that is the expert system or expert intelligence system. Another one is a formal task. So the formal task is like a little interesting, like games. So let's say if you can play the chess with the human being, you can play with the computer as well. So that's a formal task. And if that formal task can be played, because nowadays you say like there are so many smart gaming systems. In 2010, first time deep learning algorithm beat the human expert who was expert in the chess. So you can see like nowadays systems are so smart that they can do all these three tasks: mundane task, formal task, and also the expert task. If you have any questions, then you can ask me in between. Yeah. Now we are coming to the data science. So what we have learned about like machine learning. Sorry, I'm sorry. We have learned about the natural intelligence. What is artificial intelligence, and what are the applications and the task and the requirement of the testing of the intelligence system. Now, based on those definitions and theory, there is a one subset of the AI which we call is a data science. So what is the data science over here? So there are also like so many definitions of the data science, but I would say like there is a little small definition which I really like for understanding that data science is a state of art to gain insight into data through computation, statistics, and virtualization. So what does it mean over here? That means that data science is a state of art to get into the data. Okay, so let's say for example, we are having a data, we are having like records. Okay, and what does it mean by data over here? What kind of the data type? So yeah, you are a high school students. So let me discuss about that, which is also like very basic. So data nowadays, like everybody is generating the data. Right now I'm talking over this Microsoft Teams, and that records about my speech. It is collecting the data. This is this kind of digital data that we are uploading every day using FaceTime, using social media like Twitter, Instagram, and everything, and also like sending us the same email, posting on the social media like Facebook and Instagrams and everything. So we are uploading and generating lots of data online nowadays, but the data can be the different types. So what are the basic types of the data? So first is the text data. Okay, so like I mean the data that is a text data. So right now I have written something that is in a text, so that is one of the type of the data. Okay, so let's say for example, what are the examples you can say? That ABC, XYZ. Okay, so these are the text data. Numeric. What are the examples? 1, 2, 3, 8, 9, 0. Kind of thing. So these are what like I mean numeric kind of data that we are generating each and every day. The third is the graphics data. Okay, you are uploading your pictures. Okay, every day on the Instagram and other social medias. So it is generating graphical data. Okay, or we can say the image data. So image and graphics both are the belongs to the same category. And which one is the left? Sounds. Okay, let's say audio. Okay, and obviously video is also having the sounds, but video we will consider for this both. Okay, so like let's say if there is a graphics and sounds all together, so audio and video, that becomes what? Like yeah, that is like high digital data, high definition of the data. So these are the different types of the data that we are generating each and every day. So now what we are going to do with the data science, that every day each and every person on the earth is generating billions of the data. Okay, numbers of the data. I mean, the data is extensive nowadays. But can we learn something from the data? That what is the interest of the human being, where the human being is going, and what are the detections that we would be going in the future? What would the medical condition? What would be the lifestyle condition? So you see, like pandemic, what happened recently? You have heard, like there are a lot of data about the COVID-19 available online. And I have also done, some article publications, and I have written one couple of proposals about like what kind of research we can do by using those COVID-19 data which is available. So let's say right now we do not have the vaccination of the COVID-19, but if we learn the pattern of the spreading and effect of the COVID-19 of the human being, so based on that pattern, we can prevent that. So that is a big impact on the human healthcare and entire, let's say in all over world community. So that is a benefit of the data science. So let's say we can do some computation, we can do some statistical analysis of using those data. We can also visualize those data. So let's say we can see like oh, this is the data and this is the flow of the data. Right now, let's say stock market, it is using the data science. These are the applications you are seeing with the social media, YouTube, Twitter, Facebook. They are using data science. Healthcare technologies, they are using the data science. If you are owning the business and you do not have website, let's say if we are talking about some old era, in a 1991, I guess, this Tim Berners-Lee, who is the founder of the WWW, World Wide Web, he mentioned that after 10 years there will be um, generation, not generation is not right, but there will be the era that if you are not having the website, that means you are not doing the business. So if you are doing a business, you have to have the website. So that was the tradition before, like 10, 20 years. But nowadays, let's say if you are doing a business and you are not collecting the data and you are not doing the data analytics, that means you are not the business. So that is what the current era that we are working right now. So let's discuss about more like what is data and who is the data scientist. So the data scientist. So the data scientist is the someone who knows more statistics than the computer scientist, and the computer science than the statistician. So you can see like the data scientist, if it is a computer scientist, no, he cannot be the data scientist. If it is a statistician, I mean those who know the statistics, okay. If it is a statistician, no, that cannot be the data scientist. It is a combination of the both. Not only both, but also additional things. What are the additional things? So these are the additional things like data scientist can be the statistician, can be the programmer, can be the coach, can be the storyteller, can be the artist. You can add more things over here because as a data scientist, you should know and you should have understanding of the data instead of understanding of the language. So I'm actively working with the companies. I'm actively working with the other universities in their STEM development program and joint collaboration we are doing. So they are saying oh, our students, they knows the Python. So can they go for the data scientist job? So if you know the Python, that doesn't mean that you are eligible to be a data scientist. Because other than programming language, you have to have understanding of the data, pattern of the data, the parameter of the data, and any other things also story building. You should have some artistic things like, let's say for example, you have data and you need to visualize those data. If you visualize it by using like normal graph, which can be done by using a Microsoft Excel, then there is no need of the data scientist. But you can visualize it that by some artistic way. Okay, so that makes more sense that you are the data scientist. So the data scientist is having like a lot of different characteristics. And if you are like, let's say if you are in high school right now, you will be in the market after let's say 3 or 5 years. Definitely you will be dealing with this data science things. Whether you will be going in the field of IT, computer or other fields, yeah, you have to deal with the data and data science, data analytics, data visualization and everything. Okay. And that is the reason at University of Houston at Victoria, we are starting MS and BS data science program very soon. And we will provide you the information about the programs and courses and all those things. But let's continue with the examples of the data science. So what are the data science examples? The first example, which is the best example as an application of the data science in the politics. So the net silver. So Harvard Business Review, they have collected the data from the Facebook and they just give the prediction that Nat Silver won the election. Okay, so how they could tell that? Okay, and actually that was happened with the probability of the each and every state in the election at that time. So they have collected the data from the social media, and based on this data, they do data analytics, and they identified that because of the popularity of the specific person available in the market or in the society and community, they predicted that oh, this person has won the election. Another thing is Senate, those who won the elections, and that was predicted by Harvard Business Review. That was actually happened at that time when they used first time the social media data. When the first time Obama came as a president, first time they have used the Facebook data to identify the interests and the perceptions of the human being about the candidacy of the about the candidacy of the president. In addition, that nowadays, like social media has state-of-art algorithms of the data science that they can influence you in a certain way that if you don't want to go with the candidate, then also you will go with the candidate. Sometimes with the product, sometimes with the shoppings, and sometimes with other things as well. So for example, myself, I would like to watch movies. So sometimes I'm discussing about the movies with my friends over the Facebook. And what happens, 2, 3 advertise comes of the movies available on the Netflix and new releases, and they are continuously showing the demo or kind of trails, short 3, 4 seconds trailers and graphics and videos to you, that those movie I never thought that I would be watching. I watch it just because of it was influenced by the social media. So nowadays, like if you see your life, if you see your lifestyle is completely based on the reviews and the data available on the social media. If you would like to visit the restaurant, okay, mostly what you would do, you would see the Google reviews of the restaurant, and then you go to the restaurant. But you should know, it is very easy to do those Google reviews and rates online, and that's not a big deal nowadays. But that is what the requirement. And human behavior is completely based on the data available online. They do not have their own preferences, but they believe the online data which is generated by numerous people. So that is one of the applications, and these are the that natural facts that they have collected from the social media, and then they use it for the analytics, and that's what they celebrated in 2012. So that is what one of the applications. And what are the key principles of the examples? That they have used many data sources, not only the single data. So let's say they have used the Facebook, but they have used Twitter, they have used some others, so data source websites, and the poll collections that they have collected the data and everything. So they have used the many data sources, but the major data that they have used is of Facebook. That is the fact. Understand how data were collected. That is, sampling is essential. Obviously, you cannot collect all the data and do the analytics, because there will be like junk data and that cannot be useful to you. So they have done the data sampling. So let's say, for example, you are having 100 records of the data. You are using only 10 to 12 sampling to see the pattern of the rest, let's say 88 that you have extruded. So that's what known as a sampling over here. Weight the data throughout. Okay, so not only thoughtfully weight the data, but also give the potential of the data quality. So let's say, for example, you know I'm collecting the data about your choice. Okay, let's say which food do you like. If I ask you and I collect the data, so I don't only collect the food dishes. I may also collect your age and your likes, the location that you live and your like for the food, how much you are travel and your like in the food. So based on your lifestyle, I can predict that what kind of food you would like to eat or you would like to explore. So that is what weight of the data. Statistical model. I mean just like not only programming algorithms, but also the statistical model like correlation, regressions. So understand correlation, state trends, similarity. So let's say there is such kind of trend happening in Minnesota. The same can be in the Virginia and California and in New York. So what is the correlation? Because let's say in California such kind of trends are happening, and here is such kind of outcomes, and similar kind of trends you are seeing in the New York, then you can relate the you know you can relate these two states and their similarities and can find out the correlations. Then we think like Bayesian, that is one of the algorithm, or we can say data analytics technique, and check the frequencies. That is what how frequently that is happening. I mean, let's say it happens just once. The correlation or connection, it happens only just once. Then there is no pattern, because there should be like a repetition of the system. Then only you can learn that there is a pattern. Good communication skill. Okay, so let's say for example 60% probability that can be done with the communication skills for sure, and obviously visualization, validation, and understanding the conclusion. So these are the key factors that they have used in the example of the predicting whether the candidate won the elections or not. And I mean, this is a really interesting story. And if you go to the details, you can learn so many things. But just like you are starting as a high school student, these are also like heavy keyword for you. But yeah, these are the principal key parameters that they have used to predict the candidates winning and loss. I am talking. I was I was talking to one of the person in Houston, and they said like the mayor's elections are coming and the elections are coming. So what are the criteria and all? So we were discussing about like these key principles that we need to get to predict whether the candidate will win the elections or lose the elections. But that's totally different part of the discussion that we can do maybe in some other webinars and all. But yeah, this is one of the examples. The other is Netflix. So the Netflix in 2009, they announced like price of the 1 million for the building a system that can recommend you the movies that you would like to watch. And based on the reviews and the feedback of the viewers, they are recommending those movies to the others as well. So this is like little interesting things that they have done, and this is like one of the best example of the data science which helped to the company to generate their revenues tremendously high. So what is that example over here? So what they did is like they collected like lot of the data of the users, and they put it as a Netflix open competition by using these 17,700 movies, and they just gave it in 2009. They just gave it to the challenge, open challenge to the data scientist community, that if you can build the system for us as a movie recommendation system, here you go, you can get the $1 million. So they have collected the data, and they have also collected the relationship among those data and the parameters, correlations and all, and give it to this data scientist. So what they did, they just like took this many time, like starting from 2007 up to 2009. They just like predicted the specific you know the specific recommendation system where there is a one movie somebody has watched, then they can also go for this different types of movies that Netflix can suggest to the viewers. And that what happened in 2012, because until 2009 they have collected the data and then they just give it to them. So like after 3 years later, they have evaluated some of the new methods offline, but the additional accuracy is also gained that they measured that did not seems to justify engineering effort. I mean, it was not engineering effort. It was really like, scientist effort. I mean, like lot of correlations, lot of the accuracy of the data that would be needed, and lot of the correlation identification that was also needed. And they won the, they won the prize, and they just, built the recommendation system. So like, 2007 to 2009, they collected the data, and they started doing some data analytics and some statistical method analytics and all those things. But in finally 2012, these people, they got the final prize. Xavier and Justine declared as a winner over there. Okay, so what are the key challenges here as well? So these are the key challenges that they have also used, like massive data, like 500,000 users, and 20K movies, and the 100 millions of the rating, users rating on the movies, Then also like the dimensional problem, that is also like dimensionality is also was very high of those data. There were also like missing data which is not like available, and there were like random missing, so that was also one of the challenge, and it was complicated. So why it was complicated? The reason behind like I mean the set of the factors that are available in the data with the rating of the movie. So some like actors, some like directors, some like maybe locations, some like costumes. That was like also like not distinct for sure, and there were also like overfitting. Okay, so the thing is like test data and training data. So if there is a test data and they had a test data of 20 or 30%, but the training data that they have used, there were overfitting of the data. So here is one thing. What is overfitting? Overfitting in the sense what? Like the data that you need to use to train the algorithm, you are using some little extra other than the requirement. That means the overfitting of the data. And there are like some mathematical and statistical techniques available to avoid this overfitting of the data, but that is also like one extremely technical discussion that we can do. So that was related to the example. Any questions? So yeah, so what you have learned? What is AI? Applications of AI? What is data science? Applications of the data science? Now data science has a subdivision, that is a machine learning. Okay, so machine learning, just a second, I think this should be put this way. Yeah, I'm just checking if there is any questions or concern. But yeah, if you have any questions, just let me know. You can write in a chat, and I do have access of the chat, so I can see your chats as well. Yeah. So what is here? We are talking about like artificial intelligence. So artificial intelligence, data science, machine learning. Machine learning is also having a deep learning. That what we will discuss. In further discussion. But now we are discussing like what is machine learning here. So the machine learning. What is machine learning? Machine learning is a set of related techniques in which computers are trained to perform a particular task rather than the explicitly programming them. So let's say, for example, if you are programming, okay, if you are programming, then what you will do, like let's say, for example, you need to do addition. Okay, so how would you program? Okay, so whatever, like, you have, let's say 2 plus 2 is equal to 4. That kind of like so whatever like programming would be like a is one of the variable plus b is one of the variable, and whatever comes is as the answer. So this is what known as a programming. But here we do not need to do explicit programming of the data, but instead what we need to do, we need to learn or collect the set of related techniques can be used in a computer science that can train to perform a particular task. So let's say we are giving the training. Instead of like, we are saying like, okay, it is 2 plus 2 is equal to 4. So what kind of training over here? So let's say we are having like set of the data that we are collecting, and those data we are giving it to the computer system. So what computer system will do? It will collect all the variables, and then it will give you the some answers. So here what we need to do, like we need to, instead of a plus b is equal to 4, what we need to do, that a is one variable and b is one variable, and answer is the answer. Okay, so let's say for example a1 is one of the subset of the a variable, a2, that is a data point of the another data point of the a3, a4, a5, and that way, let's say an. Okay, and the same thing happens with the b, that b1, sorry, b1 and then b2, and the same goes with the bn. So here is the thing, like these all are the data points that you are having. So consider the situation that a1, let's say a1 is equal to 2 and b1 is equal to 2, that becomes 4. But consider the situation that 2 comma 2 is equal to 4, for example, answer. But let's say there is a 1 comma, let's say 5 is equal to 3. Then you cannot say this is the addition. This is something else. So you need to, like, let's say 2 plus 2 comma 7 is equal to 9, for example. So here you see, like, there is no addition happening. But based on this 3 row, same as like based on this all different rows, what you can see that there is some pattern, that value 1, variable 1 and variable 2, there is some correlation that gives you this kind of answers. So that's what we need to train. We need to train to the computer by giving this data set or this data points to perform the particular task. Okay, so that way they will, computer will learn pattern, and that based on the pattern, it will give you some outcomes. So that is what all about the data. Sorry, machine learning. So what is the difference between machine learning and traditional programming? So as I told you, like, the traditional programming that you are doing, like 1 plus 1, 2, 2 plus 2, 4 kind of thing. So what is the input over here? That the input with rules, traditional programming will give the output. So let me give the same example for your information, that how this traditional programming works. So let's say this is a traditional programming, and that works in the way, let's say for example, input is what? 2, sorry, a is equal to 2, b is equal to 2. Okay, so this is what input. Rules. Okay, so what are the rules? Rules here, addition, that is the rules, and that will give you the output is 2 plus 2 is equal to what? 4. So that is known as the traditional programming. But if you go with the machine learning, then it will be a different story. What is the different story over here? That what you need to do is, like, instead of rules here, you need to go out. So let's say, as I told you, like, data that A1 and B1 is equal to C1, for example. So what you need to do, like, you can give like data here. Let's say A2 and A3, B2 and B3, and that gives you like C2 and C3. So this is what this is what your data set. In data set what you have, okay, in data set what you have, A1 is in input. Okay, what is A1 over here? A1 is the input. So B1 is the output, believe me. And C1 C2, C3 is the, let's say for example, rule. Okay, so let's say what is the value of A1 here? So I would say A1 values is a 2. Okay, and here is a 2. Here is a 1. Here is a 3. Here is a 5. Let's say 4. Here is a 5. Okay, and C1 value, here is a 4, for example. Here is a 3. Here is a 20, for example. So can anyone write the answer in the meeting chat that what is the rule here? Yeah, this is the question to all participants, that what is the rule that applied here in this data set? This is the testing, whether you guys are sleeping or you are still available. I think somebody has written the answer. Okay, perfect. Yeah, it is multiplication. Yeah, the first one. Yeah. Okay. Yeah, I mean, yeah, we got like multiple, answers. But yeah, so this is multiplication. So the rule is a multiplication. How would we learn here? We do not know anything about the symbols, but the pattern 1, pattern 2, and pattern 3. Like you have three different data sets, and based on these three different data sets output, you can see like this is the rule that has been generated. Okay, so here you have input and you have output, and the rule is a multiplication. Okay, so this is what the difference between the traditional, traditional programming system, and the machine learning system. Okay, great. So that's what we discussed here: the traditional programming approach and the multi machine learning approach. So what we have seen is like in the previous slide that the direct comparison of the approach of the traditional programming and the approach that is taken in the machine learning. The traditional programming, we are used to provide the input data rules in order to implement the program, and usually rules are being used to implement an algorithm which is then the processing the input data, and that leads to the certain output. So that is the difference between traditional programming language, traditional programming approach, and also machine learning approach. And in machine learning approach, you can see the machine learning is a little bit different, providing input data and that related output first. So let's say, for example, you need to give the input A1, B1, and you also give the output, that is a C1. And then it will tell you whether it is addition, whether it is a subtraction, whether it is multiplication, division, modulus, kind of thing. So that is what the machine learning approach over here. With the trained neural network, then we are able to apply, this is the mistake, apply the neural network on the new input data that will able to predict the output of the certain accuracy. Okay, so let's say the same example. Let's say the same example. If I'm giving the A4, which is maybe like 8, and B4, which is 3, so what do you think will be the C4? Yeah, that's a question for you guys. Yeah, it's easy. You know the pattern. Let's say we are not writing anything here. Okay, definitely. Great. I need, yeah. Okay, so that's, I mean, I cannot recognize your guys' names from the user's ID that you are having, but yeah, that's the answer. Like, you can easily say that, let's say if you are having like A4 as 8 and B4 as 3, then C4 will be to 24, because then based on this three set of the data, you can predict this value. So definitely you can predict this. Yes. So that is what the machine learning is all about. Okay. And then neural network algorithms and other network algorithms are working based on this. Okay, fine. So the practical of data science using machine learning and using Python as well. Okay, so that is what the actual practicals comes in the picture now. We will go and I am going to show you that what are the open source tools that you guys can use and what are the other things that you guys can use to do this practical. But the thing is, mm, yeah, there is some problem that one participant is having. Okay, yeah, there will be someone to assist you. Yeah, so the practical of data science and machine learning using a Python. Okay, so let's say we all are uses the Python, but there is one of the component of the data science that can be done using the Python. So Python is not the data science. I mean, data science practical and programming language. It's Python is just normal programming language, but due to all rich libraries available in the Python, people are preferring to use Python nowadays. When I have started a data science, I was using the MATLAB. So MATLAB was we were using like for statistical analysis and some mathematical analytics. So in 2008 9, I was using the MATLAB. And then when I have implemented my dissertation of my PhD, I have used R programming language to implement this analytical techniques. And thereafter, in 2017, although I was doing really good using the R, I had to move to the Python. The reason behind that Python is having like super set of the libraries that you can use to implement your algorithm of the machine learning. And that is the reason like I moved to the Python. And that was the first time I used Python for the data science in 2017. And till today, I'm only using Python when there's something I need to do, like implementation, building the system, protocol design, or saying research design or something. I use only Python. So Python is having like really good set of rich libraries that can be used for the data science and machine learning programming. What are the main data analytics libraries are available? There are like NumPy. There is also SciPy, Matplotlib, IPython, Pandas, Scikit-learn. Not only, there are also other libraries nowadays you can see available in the market. There are also like frameworks available in the market. So what are the data science framework? The machine learning framework, deep learning framework, these all frameworks are available. Just a second. Python is advanced version of the JavaScript. No, I mean Python is not the advanced version of JavaScript. JavaScript is one language, and Python is the another language. So basically, like I mean, you can use. I mean, you can say like there are like little bit correlated with each other, but with Python, you can build a operating system, you can build a website, you can build a smart system, you can build everything because it has a lot of interfaces available. But JavaScript has like some limitations that can be used with some web development, or maybe some online system development only. Yeah. Any other questions? Any other concern? If I'm missing from the chat? Yeah. If you guys have any questions, any concern, you can type in chat for sure. Yeah. So main data analytics libraries, and the data analytics libraries are, these are the like basic libraries, but there are also like different frameworks. So let me type here that there is a TensorFlow that I'm using nowadays. The data analytics libraries or like frameworks. The frameworks right now are available in the market. I'm highly using this TensorFlow by Google. This is the best library, this is the best framework that available easily because it's open source, and it has a lot of best features that you can use it. The another one is the MS Azure with CNTK from Microsoft, obviously. Yeah, so Microsoft CNTK, the full form of CNTK is a cognitive, cognitive toolkit. Yeah, exactly. It's a Microsoft cognitive toolkit. So that is, not the free. It's only, paid version available. But yeah, if you are a student, you can get some education hours free to do like, play with that Microsoft cognitive toolkits. So that is one. There is another like PyTorch. That's by Facebook, Amazon, AWS. So these are like different services available from the different vendors as a framework with a set of like all rich libraries that you can use. Okay, and let's discuss about the data analytics libraries. The further stage is to revise and mug up is a part of the Python that is acceptable to the data science. Python possesses the vast number of libraries. I mean, you talk about like, whatever libraries, visualization libraries, analytics libraries, and, training libraries, statistical methods libraries, computer vision libraries. Python has all set of libraries. Libraries are the purely connection of the ready-made functions and objects. Now, what is the use of the library? Okay, why we are using the libraries over here? So let's say, for example, if you need to do something, let's say, for example, printing a graph. Okay, printing a graph. So if you are printing a graph, you need to write it like, big code, which is of like, let's say 40 to 45 lines of code that you need to write. If you are, using the traditional programming, writing methods and functions and everything. But if you are using library, that can be done in 2 to 3 lines, or maximum, let's say 5 lines. So that is one of the benefits of the using libraries. So if you are using libraries, you can get more and more benefits about like ready-made functions and objects available within the libraries. I'm going to show you the demo. Let's say, for example, if you are using this library, what are the benefits that you are getting? And if you are using other libraries, then what are the other benefits that you will be getting? Okay. Hmm. Yeah. So that is what the libraries are. And like how to use the libraries, the process steps. So you can see like you need to look. You can use the Jupyter notebook. So if you have a Jupyter notebook, let me show you the screen that where you can get. Sorry. Yeah, so this is a project Jupyter. So this is the Jupyter notebook that you can download from jupyter.org website and you can install, and that has all the libraries available over here. And you can also try the Jupyter notebook in your browser as well. So let's say like classical notebook Jupyter with the R, Jupyter with the Julia. Julia is the library name, and there are also like other way that the rubies and all you can try with. Let's say this is the traditional, okay, and let's say we are doing something display system. So let's click on that, and you can see like this is the functions that comes with the Jupyters. Can you see this? Yeah. So let's say there's extensions, running clusters, and all those things about the Jupyter notebook. So you can like create your own file, create your own Jupyter notebook, and you can print welcome to UHV's online data bootcamp. Okay, and what you need to do, you just need to run this one. So can you see this run here? Just click on this run, and it will display over here. Okay, you can also do the mathematical functions. Okay, let's say for example a is equal to 5, b is equal to 7, 8, whatever, like and c is equal to a plus b, and then just run. Okay, but here it will not display anything. Here you need to print. So what you need to do is like you just need to print, and c is the variable. I just need to check whether directly it works. Yeah, it's a Python 3, so it should work. So here you see. So this is what the Jupyter notebook. So you can use Jupyter notebook. I mean, demo is coming. So like so open Jupyter notebook, go over the library documentation that you can get for half an hour. Then import the libraries into your Jupyter notebook and follow the step-by-step guide of the library actions, and then you can also examine. So that is the way you can use the libraries over here. Okay. Yeah. And like I mean, another thing that I can say, like use of libraries, if you are trying the libraries that are capable of, you can simply just try like trying the libraries. So in Jupyter, you won't have to use the system.out.println. No, no, that you don't need to use. Actually, system.out.print print that is like we are using in a JavaScript, we are using in a in a something like Java, we are using it system.out.print, but println that we used to use in the older version of the Python. Okay, so in the latest version of the Python, that is the Python 3, I guess that's what we have seen, right? Yeah, this is the Python 3. So now, right now, like there is a latest version of the Python, like Python 3.8 or something. Yeah, it's a 3.8.3. It's the latest version available. So yeah, in that the latest version, you do not need to use like println. You just need to use as just print. And as you mentioned about like Python is the advanced version of the JavaScript. So I would say like definitely there are some syntax that Python has adapted from the JavaScript. But other than that, there are so many, different terminology, I mean, different categories and different functions and objects available in the Python that was not at all in the JavaScript. Okay, so but in one way, like yeah, I mean because it's inspired from JavaScript, it's inspired from C language, it inspired from different other languages as well. Yeah. So yeah, here in you don't need to use like println and all those things. Yeah, you just need to use a print and you are good to go. I mean, if you are using multiple outputs lines and all, then yeah, you can use a print ln for new line of code, but that's what not needed right now. Any other question? Hmm, there should be a conversation. There should be a show conversation in the panel of MS Team that you can use to type the chats actually here. Okay. Yeah, so Jupyter Network, Jupyter Notebooks is, I mean, this is one of the tools that we are discussing, but we are going to use the open source tool uh, from the Google, and that's free of cost available. Yeah. So Jupyter Notebook is a lightweighted IDE that is a fabric among all the analytics. In most cases, installation packages, Python is already included in the Jupyter Notebooks. So what you need to do is like you do not need to install the Python if you are using Jupyter Notebook. You just need to use what? Just install the packets. Let's say if you are using TensorFlow, if you are using some other PyTorch and all those things that you just need to install. And then you can use Anaconda Navigator. Okay, so if you are using Anaconda Navigator, then yeah, you would be having like tremendous benefits that overall control that of the Jupyter notebook that you would be having within the Anaconda Jupyter. So you will be having client, you will be having a server, you will be having a notebook, you will be having everything. So that's it. So that is what related to the libraries. Any questions? Because we are going to discuss a little bit more about libraries for 5 minutes, and then we will go for the demo because we are already having I think we have half an hour to discuss the demo before we go for the first one. Any questions? Okay, if you do not have any questions, then let me move ahead with some little
Oh,
discussion.
sir. Yes.
Yeah, you have any questions? Please go ahead.
Yes. So for a complete beginner in coding, what would you recommend to start? Where would you recommend to start?
Oh yeah, so I would recommend like start using a Jupyter notebook, and I would also recommend start using a Google Colab that I'm going to show you guys today within the demo. Okay, so like I would suggest like these two tools. The one is this Jupyter notebook online you can use, or you
Mm-hmm.
can start you do like I mean install. If you don't want to use online, you can use Anaconda Jupyter, Navigator
Yes.
that you can use to install within your system, and that you can use for programming. So that is one way. And another, I highly recommend to use Google Colab. Alright. Yeah.
Ooh, okay.
Google Colab it's an open online tool, and I highly recommend to use that tool. The reason behind that tool is you just need like Gmail account. And tomorrow's hands-on activity that we are going to do that we will be doing over the Google Colab. So you do not need to go to the Jupyter notebook and install anything and that kind of things. You just need to open a Google Colab from the website, and you need to do like, the small, interesting programming task that I will share with you tomorrow, afternoon, based on the activities that we will be decide. But yeah, Google Colab I highly recommend to use for sure. Any other questions?
Thank you.
Yeah, no problem. Any other questions? Okay, so let's finish very quick about libraries because I need to show you a lot of things in the demo, and I'm not sure like whether I can cover it or not because we are having break at 3:15 and 3:13. We have another Professor Itani is gonna speak about like data securities and all those things. Yeah. So the libraries NumPy. NumPy is a shortened form of the numerical Python, and this is the most universal and versatile library for both, for like, those who are beginners. They should start with the NumPy instead of like pandas and other libraries. I have started, programming with a scikit-learn. So I have not started with NumPy, but as per the experts and the literature available in the market, they are saying like NumPy is the best way to start. But you can start with the scikit-learn because that is also easy to learn. Using this tool, you are up to operate with a multi-dimensional arrays and matrices and with easy and it's also comfort. Such functions like linear algebra operations, numerical conversations are also available in this library. So let's say if you want to do like, some mathematical things, that is, the best way that you can start with. What is a library? Okay, so the library is the set of, let me write something here. So what is library here? It is a collection of set of functions and objects you can you can use ready-made. Okay, for example, you need to do addition. Okay, so let's say for example, there is the addition library. Okay, this is the library. So what you need to do, you need to use those library and you pass to, you know, let's say values, it will give you the answer 4. But if you are not using the library, then what you need to do, like you need to do like let's say for example, A is equal to 2, B is equal to 2, and C is equal to, let's say, A plus B, and then just let's say print C, kind of like, so you see like instead of one line you need to line 4 lines. Okay, and that is one of the drawback